Hey everyone, welcome back. Today's discussion is going to be the diode. I chose the diode because it's very close to my very favorite component in all of electronics, which is the light emitting diode, the LED. I could probably spend years talking about the LED. They're a ton of fun and there's a ton of different kinds, but we'll have to start with the basics. We'll have to start with the diodes first. The diode is actually a relatively simple device, but the technology behind it is fairly innovative. Most diodes are constructed out of a material that they call silicone. Silicone is one of the family of semiconductors, which means it's not really great at allowing electricity to flow, and it's not really great at blocking electricity either, but there's a lot of things that we can do with it. The diode, the look of the diode, usually they're pretty small components, often found on boards, and they're a little tiny cylindrical device, sometimes colored orange, sometimes colored blue, sometimes kind of an older style. They can be round. The wires are a little bit bigger on some of them, and often the wire gauge, the wire size, will indicate how much current is able to flow through it before it bakes itself. Usually the diodes, depending on the use, aren't made to handle a whole lot of current, so we have to be kind of careful with how much power we're allowing it to dissipate. Sometimes they're built into configurations where there are several wires coming out of it. This one has 4 wires coming out, and this one, same thing, there's 4 wires coming out of it. That's a component that they refer to as a bridge rectifier. That turns alternating current, which travels back and forth both directions, into DC, which is direct current, only a single direction of electricity flow. That shows up a lot in especially linear power supplies, but also in switching power supplies. I'll cover those a lot more in depth later. The use of a rectifier is a pretty interesting tool. Sometimes, again, on older style diodes, they have a metal canister look to them. Be careful, because sometimes you'll see diodes that look a lot like this, but they'll have 2 wires coming out of one end of it. That's not a diode, that's a silicone controlled rectifier, an SCR. So just be a little bit careful with those ones, but fortunately they don't show up very often in most technology today. And then of course everybody recognizes the usual suspects, the LEDs. We've all seen those. Sometimes, here's my favorite ones, the ones with 4 wires coming out of them. The 4 wires coming out indicate that it has a red, green, and a blue, and sometimes the 4-wire ones are these daisy chain, serially connected LEDs, and again, lots of fun. There'll be a lot on LEDs, they're pretty cool. The basic idea behind a diode, if we were to think about it at its most simple definition, is a one-way valve for electricity, although there's a lot of different uses. I often visualize it as taking 2 fingers at different levels with each other. Now imagine these as being potential levels, or the amount of energy required to get electricity to flow. Now one side is supplied with a whole bunch of extra electrons. They do this by taking the silicone material and adding other atoms that have a bunch of extra electrons. Then on the other side, they add material that has less than a surplus of electrons, kind of like when I was talking about capacitors and mentioned there being positives. There's not positives, there's just a lack of electrons. So on one side, there's a lot of electrons, on one side, not very many. Well, on this side, with a lot of electrons, if we supply a little bit of potential, supply a little bit of extra voltage, then the electrons can travel to the other side quite easily. So we apply a little bit of electricity, usually less than a volt is required to hold a diode conducting. They call it forward bias. A little bit less than a volt, and electricity can travel freely. Now, if we apply the voltage from the other direction, we have to apply a lot of voltage to bring it up to that energy level and then jump across to the other side. So we can get a diode to conduct if we plug it in backwards, but it takes a lot of voltage in order to get that to happen. Usually on a lot of diodes, the simple ones, that type of voltage is enough to damage or destroy the diode. But on some diodes, like the Zener diode is an example of this one. It's made to actually apply a certain amount of voltage, which they can choose how much voltage that is. The manufacturer can select how much voltage is required to get it to conduct in the opposite direction. And once you remove that voltage, the diode is still fine. It didn't actually destroy itself. But LEDs, switching diodes, rectifier diodes, if we apply too much voltage in the reverse direction, they will probably be destroyed. They're pretty tough usually, and when they're used properly. And one of the nice things about diodes is that there's no moving parts. So although they can control the direction of flow, they don't have moving parts, so they last a very long time and are very reliable devices when used properly. Now, most diodes, when you apply voltage in the forward direction, it's about 0.7 volts, somewhere around that vicinity, a little less than a volt. But depending on the application, like LEDs, they require a little bit of extra energy, because not only are we going to conduct electricity when it jumps across, but also we're going to be giving off even more energy as light. So that means it's going to take more energy to run those LEDs. Usually those can be a couple of volts. Still very efficient when you compare them to traditional electronic light emitting devices like an incandescent light bulb. They're way more efficient than that because they don't generate a lot of heat. That 1 volt is less than a volt is required to turn it on and leave it on, but often they'll have a power rating that's no more than a couple of hundred milliamps for some of the smaller, or milliwatts for some of the smaller ones. And that means that we're allowing very little current to flow through it. Many uses of the diode, I talked about the bridge rectifier in power supplies. It turns AC into DC, but in some cases we also simply want to keep electricity from flowing backwards. Sometimes you'll have a device that's a motor-driven device, and if somebody were to take that motor and give it a spin, it's going to generate some voltage. That voltage may send it back into the control board and potentially destroy the control board, and those can be pretty expensive. So the diode can allow the electricity to flow out to the motor easily, but can prevent electricity from flowing backwards into the device that was driving it, usually a very sensitive control board. So we can use it to configure very carefully the amount of electricity, or the direction of the electricity flow. That other one that I mentioned, the Zener diode, that one's a very particular use diode, because since they can control the amount of voltage required to allow it to conduct, we can use that to allow a certain amount of voltage, up to a certain amount of voltage, to supply other devices, like maybe we have a circuit that needs 5 volts. If at any point the voltage goes above that amount, instead of sending that back and damaging the components, we allow that voltage to simply bypass through the diode. And it keeps the voltage at a very safe level. So we can use them as a very simple regulation of the amount of voltage to supply to devices. Other types of diodes, obviously the LED, we know what the purpose of the LED is, and it's just to light up. Great as indicators, great for a lot of really fun devices. And my cabinet back there is loaded with all kinds of LEDs, multicolored stuff. They're a lot of fun, but diodes by themselves have a lot of different uses, and they're a pretty interesting device. So pretty soon I'll be talking about LEDs, but just wanted to cover the basics of it, because there will be a lot of things that we have to consider, like how to plug it in correctly. If it's not working, we can turn it around and see if it works. And it's kind of hard to understand if we don't really have the basics of a diode and how it works. So this is kind of the part 1 of diodes. There will be a lot more about those in the future, but they're definitely LEDs, and that family of optic devices are one of my favorite ones to deal with, so I'm sure I'll be spending a lot of time on that one. So definitely check out the other videos and stay tuned, and there will be a lot more to come. Thanks.